So Break to Educate is a little bit different than our Lunch and Learn series where we talk about core SolidWorks. This gives us an opportunity to talk about the other products that SolidWorks has to offer, specifically SolidWorks Electrical today. And we'll be looking at how SolidWorks Electrical collaborates between the 2D software and the 3D software, while at the same time giving an overview of how electrical works as a product itself. So kind of to set the baseline today of how collaboration works or how communication works, we're going to look at communication throughout history. So communication pretty much started well into the BCs using a messenger. So a messenger would carry a letter from one castle to another castle, travel across land, and use his feet. It was a self-powered machine, really. So this effort is very time-consuming, very inefficient, and exhausting for this guy, because if anything was wrong in the memo or in the letter, he had to huff it back, then go back and return the response, which was a very exhausting process. So later on, at the start of, let's call it the 17th century, I'm making up numbers now, we fixed this process, and we developed a tool to help communication, to help this letter carrying process. We started the Pony Express. Again, still a time-consuming process that you're going from spot to spot, and it's slow back and forth. Even though we have a new tool to enable this communication, it's still a arduous process. That is, there's an error in the memo, or if somebody moves and you don't know about it, it's still going to be a slow back and forth. So moving further into the future, we now have a mailman, or a post office, UPS. So we've been able to maximize the potential out of this mail delivery system. We have networks in place. We're able to pool all the mail together, divvy it out based on zip code. So we're getting better here. Still have issues where we require to know our contact's location. So we can't send a letter without an address. And it's not guaranteed feedback. If that person's on vacation, they're not getting that letter until they return back to their mailbox. Finally, late 80s, early 90s, we get email. Everybody can use email. It's instant, and it's right at your fingertips. So with email, there's an ease of use that anyone, all ages, can use it. It's consistent that you're going to type up your letter, type up your email, hit send, it's going to go to that person. And that person can get it on their phone now. It can be instant feedback back to you as a response. We also have some automation built into email where you can set up your signature. You can set up an out-of-office. You can link up your calendar right to your phone. All right, so what the heck does this have to do with our Break to Educate today on SolidWorks Electrical? What I try to convey here is that our letter carrier, our messenger, is similar to doing a schematic either in PowerPoint or on paper and pencil, so hand-drawn schematics. It's still going to be very time-consuming. It's going to be exhausting for the designer that's doing it using these methods. For our Pony Express example, we stepped it up. We've added a tool to help enable us to do these, but it's still time-consuming. So this is using Visio and then creating some to-from lists or bill of materials in Excel. So you're getting tools to help you, but you're still kind of turning your wheels and crunching some numbers to get it done. So our post office, I compare to AutoCAD Electrical, where now you have everything centralized, but you still require to know what your mechanical designer is doing, or what your where your electrical designer stands, and you're losing that communication back and forth and instant feedback. Whereas our email example, I'd relate to SolidWorks Electrical, where we now have that constant feedback between one another, and your softwares are now talking, collaborating fully. So today, just kind of my overview of, or introduction into SolidWorks Electrical for those who haven't seen it. Based on the list, I know some people have seen it, some people are currently using it. Just a high-level overview of how we're going to look into this product. So you're going to start by looking at the user interface. So how does an electrical designer create a symbol, place a symbol, update a symbol. And then how are they going to allow symbols or components to talk to one another? So how do we draw wires? How do we update wires and label wires? And finally, as our projects grow, how do we keep those organized from page to page and using some arrows across wires? We'll then jump into our 3D design. And I call this 3D design for EEs because it's not really your normal SolidWorks where you're sketching a component, you're extruding it, you're cutting it. You're still kind of leaving that for your mechanical guys to design your components of an assembly. Where we use SolidWorks Electrical in the 3D space is placing 3D components, routing wires and cables, and doing some cabinet panel layout drawings. So making that as simple as possible for the EE. We're accomplishing these tasks that are rather difficult in certain softwares. We're going to try to streamline that and make it as easy as possible in SolidWorks. And the last thing to kind of stress this communication between the two softwares is the ability to do live updates between users. So when a component is created in 2D, we get to see this update in 3D. Same as when a component is deleted or changed in 3D, we'll see that update in 2D. As well as the communication tool that's built into SolidWorks Electrical. We'll look into how that can help communication and keep everybody on the same line. All right, so with that, we'll start by just kind of going through the typical electrical design process. So for an EE, like I said, it could be pen on paper, it could be in Visio. But either way, what they're going to have to do is start with a drawing. So every time you're going to start drawing your wires, drawing your symbols, selecting parts, identifying what's going to get wrapped into a cable, you're going to design how your circuit needs to work. And that's all comes in the drawing phase. From there, we have to document everything that we just drew. So we're going to create our bill of materials based on the symbols we selected. We're going to do a to-from list based on how we drew our wires and our cables. And then we're going to try to number our cables as best as possible, make sure we're not skipping any numbers, duplicating any numbers. The last step in the process is to review that work that we just did. So look back at the drawings, make sure our logical definition makes sense, make sure our BOM isn't, our bill of materials isn't duplicated anywhere, make sure mechanical guys line up with our electrical guys, and we're not trying to order two parts or different parts. It's just kind of that final check to say, yep, this is our design, we're ready to move forward. If anything in that audit turns up a finding, pretty much start back at the drawing. You can't just change the document because then your drawing and your document don't match. So you're starting back, you're making your changes, and then you're going back through your process. So what I hope to show you today in SolidWorks Electrical is a tool that's going to help us draw easier. We're going to use efficient design tools built into the program to help lay out our schematics in a logical path and have the ability to update on the fly. The nice part about the tool is it automates the rest of this. So everything after our drawing phase gets automated into documentation, and updates, like I was saying, updates is easy, so if anything does turn out in the design phase, we don't really require that audit. We can fix it in the same phase. I'll be walking through two products today. We'll have SolidWorks Electrical Schematic, which is a standalone tool that we're going to do our design in. And then we'll go into SolidWorks Electrical 3D, where we'll route some wires, we'll place our components, and then we'll look at a full-scale assembly. Now, here's where our communication really hits home, are that these two tools are talking to one another. So a change in schematic will update 3D, a change in 3D updates 2D. You're getting constant collaboration over collaboration server, which I'll go into for a bit. All right, so we're ready to look at our user interface. We'll place some components, we'll draw some wires. We'll just kind of go high level into SolidWorks Electrical. So I'll open up Electrical here. All right. So right now I'm looking at a document tree. You'll notice that my document tree has a cover page, a drawing list just to identify what's actually comprised inside of this. So we have a bunch of schematics and drawings and a couple of reports coming out of it. What we also have is some assemblies. So we have a piping assembly and a main electrical closet. And I'll get into those once we touch on the 3D. But I just want to point out that our 3D assemblies and parts are located right inside our project. And our project is really just an archive of all our components, all our documents, and all our 3D parts living inside a server. So we'll go into the structure a bit, but for the meantime, this is our document tree, and this is where our schematics are going to live. In here, we also have components based on location and lower level locations. We have some macros if we decide to use anything. I don't think I have anything created right now. As well as our symbol library. Our symbol library consists of any symbol that we can use in a schematic. All right, so what I'm looking at here is a single line diagram of a pump. So we can look at this high level picture and try to understand what we need to design here. So we know we're going to take water out of somewhere, push it through a pump, and this pump should have a couple sensors, which we're looking at here to see where the water's going or where it needs to get to. It's going to have a motor to actually move the water. We're going to have a terminal block that's going to talk between these sensors and the motor. So we can see we have a couple wires identified, a couple locations identified to better lay out how our project's going to look. So from this high level, we're going to dive down into our lower level. So we're going to start to draw our schematic based around our design. Our motor symbol, which was pictorial before, is now going to turn into a motor scheme symbol or multi-line schematic symbol. And what's nice about this program is as I look at this motor, I realize my design requires two of them. What I can do is go ahead and right-click and do a copy and paste. And what this does is redraws my motor, but it updates it to the next number. So because M2 already existed, it decides this is M3. I actually want to associate this to my existing motor that was up in that drawing, which was called motor 1, or M1. So I can associate it through my symbol properties. It gives me a notification that this symbol will be associated. That's what I want. Go ahead and hit OK. And with this updates to M1. I'm still in my L2 location because I'm living inside a location box. That looks good. Now I want to connect this to the rest of my circuit. So I have to draw some wires. Coming into my schematic tab, you'll notice that my layout's a lot like SolidWorks, where I have this feature bar up top. I have a side panel that controls my documents and my components. For this, I want to do a schematic, and I'm going to draw multiple wires. As I look through which wires I have options for me, I realize that I'm looking at 3 phases with real colors. I have the ability to turn on and off some neutral wires, or I can split out my phases. For this one, I'm going to turn off my protection wire. And as I hover orthogonal to points, I get my dotted line, much like SolidWorks, to show where I'm represented. So for this one, I want to come from my neutral or my phase 1 wire, so this red line, and I want to draw down to my motor. So I'm going to left-click here. I'm going to pick the direction of my wires. I'm going to go ahead and draw them. So you'll notice that I'm going to draw right past my motor. And as I left-click and right-click to cut them, my symbol's smart enough to know that it's a terminating symbol. So it's going to trim my wires for me. There's no trim command needed. It's just going to meet up with this connection point, trim them, and now these wires are connected. All right, I want to add a couple more symbols. Where I did a copy and paste before, this time I'm going to use my symbols library and look up. And for this one, I did a find command. So you can do a find, and it will go through all the symbols that you have available to you. For this one, I want a 3-phase, or I'm sorry, a 3-pole fuse disconnector. So I type enough there, enough of the description there to identify the symbol I want. Now I can just drag this into my schematic. I'll make sure I hover around my phase 1 here. I'll go ahead and drop it down. Every time I choose a symbol or bring a symbol in from my symbols library, symbols palette, symbols properties manager pops up for me. And what this is enabling me to do is to better identify what this symbol is. And what it wants us to do is identify a manufacturer part for this, because the manufacturer part is going to build your bill of materials. It's going to be where you get all your information about this circuit, about this symbol. So for this one, my location looks okay. This part's going to go in the chassis of my main electrical closet. What I do need to do is choose a manufacturer part. So I go through my manufacturer parts. I'm going to do a search here. Another window pops up, and this is how I'm going to filter for the part that I need. So I'm looking for a Legrand, and my part number is 00573. I'll hit search. It'll go through my database. It'll find the part that I'm looking for. This is the one I want. I'll add it to my library. I'll select it. We'll notice that I now have access to this part, and that it's got 6 terminals associated with it, 3 circuits. So 3 inputs, 3 outputs. So that looks good for me, and I go ahead and place my symbol in there. It updates with any of the metadata that's associated to that manufacturer part. So you'll notice that my symbol, I can't really tell who my manufacturer is on this. So I do want to make a quick update to this symbol. I can do that by right-clicking symbol and open it. And SolidWorks will launch a new window. SolidWorks Electrical, sorry. We'll launch this new window, or a new tab. And I now have access to the attributes that are being pulled for this specific symbol. So I can see my connection points. I can see my point tags, so the call-outs for these 6 connection points. I have some of my personalized data here. But what I'm really looking for is my manufacturer part information. So I can grab that by inserting a new attribute. For this one, I want my manufacturer and manufacturer part. I'll hit OK. I'll go ahead and drop them in. I can see that these are all going to be oriented based on a left side margin, which I don't really want. I want it to be a right side. So I can go ahead and make a couple tweaks here, bring it back over, and line it up with the rest of my symbol. Do the same for my manufacturer part. Bring it over, drop it down. Great. So I'm going to exit out of this, and it's going to let me know that I can have the ability to save the changes here. So I'm going to say, yep. And now I'm going to update my symbol. And with that, I get my manufacturer and my manufacturer part number. So pretty easy way to update a symbol. I just did it through attributes. You can relate this to editing a symbol to better suit your company needs as well. So you don't draw a 3-pole fuse disconnect like this. It's easy enough to leverage the information that comes with the software and create a symbol that better suits your needs. And all that is through the edit symbol, or the open symbol, and making edits there. All right, so I dropped that symbol in. I do need another power contact in here. So I'm going to do a search for a 3-poles power. I get every description or every symbol that fits this description. We get a couple different options, but this is the one I want. I'm going to go ahead and drag and drop them in. And this time, kind of like what I did with my motor, but a different sequence of events, I'm going to associate this to another part. So I can look at my K1 part, and I can see that there's 4 symbols already tied to this, as well as 2 SolidWorks parts. So looking at this, I can go check out my manufacturer part and say, yep, that looks pretty good. That's the one I'm looking for. Go ahead and hit OK. And what this does is update with my manufacturer part information from K1. And if I want to see where K1 is also used, I can come through my components tree and double-click, and it will launch anywhere that this component or manufacturer part is being used. So in my control scheme, I have a switch that's called K1. I have another normally open contact here, so another switch in my control scheme. So you can see 2 K1s there. We have a relay coil being used in the control scheme, and then another contact here. So normally closed contact in my PLC inputs. So I'm not going to go too much into PLCs today, but the capability is there, as well as tying in circuits to that PLC. So that looks pretty good. The last thing I want to do is tie a terminal block to these 8 wires that I just drew. So I'm leaving my control cabinet here, or my main electrical closet, and I'm tying into a motor. I don't want a direct line to one of these. I want something that can break if I oversurge, if I'm overheating. So I insert terminals by doing insert end terminals. I can see that I have a disconnectable terminal. And all I have to do in order to put a terminal onto all 8 of these lines is draw a wire across, choose which way the electricity is flowing, and then I'm going to associate it to an existing terminal block. So X1 will be that. I'll say OK. What it'll do, it'll pick the next numbers in line. So X1 already had 4 terminals associated to it. By hitting OK, it's going to add these next 8, starting with 5, going up to 12. The only thing that I missed by doing that is assigning a 3D part or a manufacturer part to these. So it knows, SolidWorks Electrical knows it's in a terminal strip. I just have to give more information to that terminal strip. So I can right-click and do Edit Terminal Strip, and that will launch my terminal strip editor. So in here, I get to see where my wires are coming from, which type of wire or cable I'm using, the manufacturer part, the location on a sheet, again, the destination, so where this output of our terminal block's going, and again, any cables or wires being used. For this part, I just want to add a couple, or associate a manufacturer part to my new 8 terminals. I'm going to assign a part. It's going to be an Intrelic, and my reference number is going to be 0115 12914. Excuse me. All right. So that search yielded one result. That's the one that I want. Looks good. Just like that, I now have all my parts associated. I can hit close. You'll notice that I never have to hit OK or save. Because SolidWorks Electrical is built on a SQL database, it's constantly being backed up and saved. So I do have the option to save, but it's really based on the time that I set to the program to constantly be saving back to that server. All right, so I now have a terminal block. All my parts are numbered. The last thing I want to do is assign a cable to this. So if I look back up top, I have a couple cables designated to go from my terminal block to my motor. Down here, these are simply wires that were drawn earlier. So the last step I have to do is associate these to a cable that already exists. So this one, I'm going to assign to W9 based on my single line schematic. And this one, same method, associate cable core. I'm going to find the function. This one I'm going to associate to W8. So with that, my colors change. So I'm no longer in my ground and 3-phase wires. I'm now looking at a cable, which I designated to be a gold color. And I get a call out for my cable number and my line type. So that description looks good. I think everything looks happy. The last thing I want to do is put some line numbers or wire numbers onto these wires that I just created. Under my Process tab, I can number new wires. I say yes. And now I get my line 1, wire section 3, phase 2, wire section 3, and so on across my project. What this does mean, though, is I have lines over here that terminate in the middle of space. So that's not a great design. What this is showing is that I have another sheet open that is looking for these lines. So I have wire 16 up here, wire N3 down here. On this page, though, I have wire 1 and wire N2. So if I want to link these two together, because I know that my output from my symbol here is going to go to that control scheme, I can use my schematic tab and origin destination arrows as an interface to link these two models up to one another, or these two sheets up to one another. So I'll zoom out. I have control of my power scheme here, then my control scheme here. I'm going to do a single insertion just to show you how this tool works. So what you'll notice is as I hover over any line type, I get a green circle. For this one, I'm going to take my ground. When I hover over my other sheet now, I can only select an endpoint of that identical wire type. So for this one, it's going to be my ground. We'll notice that I get a origin destination arrow there. Oops, my mouse fights me here. As well as an origin destination up top here. So I'm going to do the same thing for my neutral wire. Single insertion, I'll hover. And again, I only get the selection option for this matching wire type. We'll go ahead and close that. And we now get a hyperlink between our two reports. So it's going to show me which row and page and row number these are located on, and I can snap between my two sheets. What we also notice is I get this large dot that appears. And this is telling me that I have a mismatch between my wire 1 here, which I'm telling is the identical wire with a magically number 16 over here. So I have to clean that up. So if I right-click on that wire style, I have an equal potential conflict. So it's showing me that I have wires running into one another that are marked differently. So I'm going to go ahead and solve that, change all these wire types to wire number 1, and that cleans that up. So I can jump back to my other drawing and do the same thing for my neutral line. I'm going to solve my conflict. Everything's going to be called N2. Gets cleaned up. As I jump my page, this is now updated to N2. So it's giving me the ability to keep everything organized and talking correctly. All right. So during that real brief overview, I'm just touching on some of the symbols, some of the functionality of the software. We were able to create a symbol or edit a symbol and then place it inside our schematic. We did it a couple different ways by copy and pasting, selecting a manufactured part. We played with our wires, so we drew wires, we changed some wires and associated it to a cable, which we'll see in the 3D space. We're able to update our numbers and add some labeling to each of those wire types. And the last thing we touched was origin destination arrows, so coming from one page to another based on wire numbers, and then correcting any conflicts that those origin destination arrows made. So for the next part here, I want to look at our 3D design now. So SolidWorks has this electrical package, which is meant to play into SolidWorks. That makes the most sense for the company of SolidWorks to own this. So what we can do is leverage this information that we just drew in our schematic and put it into our 3D space. So again, from my document tree, I'm going to launch my mechanical closet. So out of my 2D software, I launch my 3D software. So those familiar with SolidWorks, this is very familiar looking. It's a SolidWorks assembly. I'm working inside a 3D space. We do have a couple differences from your normal SolidWorks look. So the first one is I have routing turned on. So I have piping and tubing and electrical routing options available to me. I also have the SolidWorks Electrical 3D tab. So this gives me access into my projects manager. So any program that I'm running, or any project that I'm running inside of SolidWorks Electrical 2D, I can create drawings from here. I can update my bill of materials. And then our key ones here are the ability to route wires with a button click, route cables, and route harnesses with a button click. I also have an electrical manager on the left side, which looks identical to my component tree from SolidWorks schematic. So if I come back into my components tree here, same components, now just represented into a 3D space. So now we have 3D parts associated with our components. We also have our project manager on the right side here. So we have our schemes that we can look back into our 2D project to see what that designer's working on. So I can look back and be like, how was I really planning this circuit? I wanted S1 to talk to S2, get over to K1. All right, so that makes sense to place them in my panel box like this. So it's just a easier access to one another's projects. So looking at this, I can tell that I'm missing those new components that I put in. And I can even simpler or more simply find that out by hiding my already inserted components and looking to see what still needs to be placed. So for this whole project, I still need to place F1, which was that disconnector that we put in, as well as my 8 terminals that I brought in. So the first one I'm going to place is F1. I'll right-click and do Insert. And all that's required, because I have SmartMates turned on, is to hover over a rail. So in SolidWorks Electrical 3D, a rail knows when it's a rail, and the component knows how to snap to a rail. Go ahead and save that. So all I had to do is hover, and with that we can see that, yep, it's mated. It can still slide side to side, so it's not fully defined yet, but it is stuck to that rail. Similarly for my terminals, I'm going to go ahead and select them all and bring them in. So if I need to change my order, if I need to add any other spacing bars here, I can do that through my insertion order. Go ahead and hit OK. And again, I'm just going to hover over this rail, define some spacing. So I want to go to the right of this. I don't need spacing for this terminal block. And I'll go ahead and let SolidWorks Electrical populate this for me. So with that, I got all new 8 terminals put in. Slide them over, make sure it makes sense. And that looks good. Now when I come back and refresh my already inserted components, I can see that, yes, everything that I did on a 2D schematic is now inserted into my main electrical closet. That looks good. The last thing I want to do in here is actually route my wires now. So I said it earlier, with the click of a button, I can start to pick and choose, or I can start to show my schematic in 3D space. If you haven't noticed, I'm using SolidWorks 2015, so we have a new feature built into this, and it's called Show Errors. So my routing analysis will now pop up if anything looks out of place. So I'm going to do a SolidWorks route so I can get some diameters onto my cables. Move this guy so we can actually see it at work. And what SolidWorks Electrical will do now is use connection points out of my schematic to identify a to-from list. It then leverages that to-from list to create routing paths. So it'll optimize my routing internal to this cabinet purely from my schematic. So it finds all the connection points inside my 3D space. It finds the shortest line, which was that yellow line that popped up, but then knows it has to snap to a rail or a predefined path. Not a rail, I'm sorry, a duct. So it'll always try to go to the inside of a duct, or if I went ahead and defined a path, like I'll do for the door, it'll snap to that path line. So currently I'm not touching my mouse. I'm letting the software run, and it's doing this based on wire type or line type first. So it went ahead and did all my phase 1 wire, phase 2 wire, my neutral wire. And it's going to complete by doing my control wires, which will run up to my front panel. So where all my buttons and switches are on the front panel, that's all going to get controlled via control wire. So a couple more wires to draw here. All right, last one. So you notice everything is being bound by a connection point. And all these electrical components that we placed on the rails, I used the component wizard to identify its connection point, how it's going to snap to a rail, so if it deserves a rail mate or a door mate, the faces of the 3D component, so to know if I need to space evenly amongst the rail, it can space between a left face and a right face between two components. So all that information has been put into each of these components. So they really are smart components when they get placed into the 3D space. Like I said, identify faces, identify connection points, link up to a manufacturer part. So once that's completed, we'll get our pop-up to show if anything failed during our routing. So close here. There we go. That looks good. Looks like everything's got a connection point. All right, so we do get our analysis now. Like I said, new to 2015. And what this will show us is any manufactured parts that we have in our schematic but not in our 3D space. So these, I can look through this list and realize that these are valves part of my main assembly, the motors part of my main assembly. So these are external to my panel box. So I'm okay that these aren't inserted right now. I'll get to them in a bit. Any manufacturer part inserted twice, this could raise an alarm. For this instance, though, it's my ducts and my rails that were inserted twice. So that was a conscious decision made. I can go ahead and it will highlight the errors that it's throwing at me. So if I click on this duct, it will highlight it. Any of my rails, it will also highlight. So this I'm really okay with because I have multiple of those manufacturer parts. Missing connection points, I do get a little nervous about. So I have two components here that are missing connection points. So as I zoom in on them, I can start to identify where my wires are missing or why they're missing, because it looks like I'm doubling up on this connection point. So that's just going to require me to go back to my schematic and clean up and make sure that I'm not duplicating anywhere inside my schematic. So an easy analysis tool to make sure that our models match our schematics, and our schematics are going to work in real life. So that looks pretty good there. I have everything routed. I'm just going to turn off my sketches so my wires look pretty clean. But you'll notice that I get different diameters based on my schematic properties. So my wire types have different diameters and bend radiuses built into the tool that SolidWorks will then follow based on rules. So if I'm happy with my panel box, what I can do is use my SolidWorks Electrical 3D tab and create a 2D drawing. And what this does is launches a SolidWorks drawing. I get my palette over here for my views. So for this instance, I want to use the front view. I'm not too worried about my side view right now. I do want to up my scale a little bit so I can see all my components. I'm going to change this to custom. Go 1 to 2 maybe? A little bit big. 1 to 4. All right, that looks pretty good. I'm happy with that. I'll drag that down and make sure that all my components are there. That still looks pretty good. So now what I can do is I can create a electrical and mechanical bill of materials. Because my mechanical parts are this box, are the rails, are the ducts. My electrical components are all listed here as well. So I can create a bill of materials based on this drawing or based on my model. Just some things to get it to fit. Slide that over. Whoops. Slide materials over. Pretty close. What I can also do is auto balloon this assembly now to match my bill of materials. So I have an instant drawing that I can give to purchasing and put it back into my electrical design. So with that, I have everything numbered, laid out. I have all my quantities listed. If I gave it a description based on my components, that would also fill up in my bill of materials. So a pretty quick way to generate a panel drawing or a panel layout with a bill of materials that's linking our electrical and mechanical. So again, enabling that communication across the two groups, or giving the electrical designer the ability to do mechanical design and quickly do a panel layout versus trying to draw the outside of this cabinet, then redraw each component based on 2D space. A lot easier to drop it into 3D space, lay it out, and then just take a picture of the front panel. So what I can do is I can create a project drawing based on this, and that will go ahead and populate inside my electrical project. So the last thing I wanted to show inside of SolidWorks is the ability to take a small panel and populate it into a larger assembly. I talked about using some cables, so the last thing I'm going to do is open up my full-scale assembly and route a couple cables internal to it. Let that drawing finish up. So back in my 2D space in our mixed power scheme, so I called out these cables, and when I look at my, when I look at my synopsis or my single line drawing up top, I can start to see that my sensors are called out as being a part of the pump. So this is just saying that my drawing was successful. It has now updated my electrical project, and I now have a drawing built into my folder or my project folder. So that's good news. I can close that, save it. Sure. Okay. So we're good with our panel layout, drawing, and bill of materials for this subassembly of our large assembly, which is this pump. So now that I'm good with this, we'll notice that our terminal blocks are connected up top, but we're not talking to anything else. So now we need to link up to our motors. So again, I'm going to launch an assembly from my electrical project documents. All right, so we'll rebuild this. So now what we have is that assembly box that I just finished creating is updated into my 3D space, so into my full-scale assembly. So again, the communication between these two is I'm changing a subassembly, it's updating my full assembly, my top-level assembly. So everything is now talking across projects. Again, I can use my information from SolidWorks electrical schematic, and I can go ahead and route cables. So just like it did before in our panel box for wires, it's going to identify our connection points. It's going to generate a to-from list, and then it's going to draw out those cables. For this one, I did have to identify a path for these cables to snap to. Doesn't appear they wanted to route this time. Let's try that again. So I'm going to clear some of my old harnesses here. All right, so those are all internal there. So let me do route cables. Not seem to want to play with me now. That's too bad. Let me just make sure that I have everything identified here. Yep, the pump assembly is okay. Main electrical closet's okay. It's a little bit of on-the-fly troubleshooting here. Those out again. one last try. Cables will show our errors this time to see where I'm missing it. These lines, go ahead and do it. So the ability to show errors will help my troubleshooting here to see why my cables are not being generated. Let's see what it comes up with. 25 errors. Missing some 3D parts. So I messed up my cables somewhere along the way. And they're not playing nice now. So something that I can now go back and play with and try to fix. We'll get our cables cleaned up and fix it that way. So I apologize for not being able to show that. All right, we'll hop back into our PowerPoint. So we were able to do our panel layout, and we could route our components in 3D space. I broke my cable relationship somewhere along the way, so I'll go back and fix that. The last thing I just want to talk about is how all this stuff is working together. So I've been saying component and symbols and 3D part, SolidWorks electrical, SolidWorks mechanical, how these are all linking together. So everything for this is built on a project database that uses SQL. And this is what's enabling our collaboration. So what this allows us to do is have our single line diagram talk to our 3D mechanical design, our drawings, our schematics, and vice versa. So an update in the schematic will update the database and relay back to our single line diagram and our 3D drawing. Now, as far as using my terms, so a symbol has many different meanings. It can be a schematic symbol. It can be a single line diagram symbol. It's really a pictorial reference of a manufacturer part built inside of SolidWorks Electrical. So once I choose that symbol, a part is being assigned to that symbol. And circuit information is coming with that, terminal information. And we're using those symbols to connect to one another. So now we're drawing wires that are connecting one symbol to another, either as an individual wire or as a cable. And once those connections are made, we're bringing in a 3D representation of that manufacturing part into SolidWorks and using that interconnection information to go ahead and route those parts. And again, everything's getting related back to this symbol in the schematic, which talks to our SQL database. So any information getting pulled from the SQL database can be translated across the many different facets of these two programs. What SQL allows us to do is search very quickly across our database. So we can search for a single line diagram symbol, a multi-line schematic symbol, our 3D part, or 2D footprint. So we did our cabinet layout a little bit different than how I did it there, is that we can use a 2D footprint that's predefined and drag and drop it into a drawing versus just doing that snapshot of our front view. We can also pull in any metadata from an ERP system, and we can customize our designs using some wizards and import tools. So we can edit any symbol. We can create new diagram symbols on the fly with a couple easy tools. So bringing it back to our history of communication, where we were started with some painful methods, and we've gotten to our email phase where anyone can do it and it's quick and easy. Hopefully I was able to show how SolidWorks Electrical can be very easy to use. The pop-ups make sense when they pop up. It forces you into a better design for an electrical schematic. Its consistency helps across our electrical and mechanical groups, that if I place a sensor and I define a manufacturer part, the manufacturer part that's getting placed into our 3D space is accurate. And then as far as the instant feedback goes, I just want to show you quickly here. As I look at my electrical schematic here and my panel box here, so I'm going to drag this one over to the right side. I'm going to look at all my parts. For this one, I want to focus on F1. And as I scroll to my schematic here at F1, look at our component tree. So, is that our chassis? This up. So we have F1 here. So F1 is being represented by our symbol here and our 3D part. Where this relationship comes in handy is if I delete F1 out of my schematic, first thing you'll notice is that my lines heal up. But the next thing that you notice, this guy tried to hide, is that F1 is now removed out of my 3D space instantly. So I no longer have a part to place here. However, if I do undo this part, F1 now comes back into my program, again, instantaneously. And it remembers where it was. So we'll still keep it hidden because this is now a change, but I can just re-show it and get it linked back in there. As well as if I insert any other symbol. So if I insert a new symbol, we'll call our root of it new. So new one has now been placed. New one instantly comes into my 3D space. So that instant feedback and instant collaboration is very powerful between these two tools. And the automation comes in with reports. So I created that bill of materials using some SolidWorks features, but I also get some project reports built into SolidWorks Electrical. So I have a PLC report that will show me my addresses, so any inputs and outputs. I get a list of cables that I was using, so I identified cable 8 and 9 to be used in my main assembly. So I can pull that information out and see where it's going from, as well as any length associated with it. We also get a bill of materials, and this one's pretty powerful, so I'm going to generate this drawing. So bill of materials grouped by manufacturer. So this one is powerful because it enables our mechanical bill of materials and electrical bill of materials to be synced up. So if I come into here and I look at my bill of materials now, so I still get my quantities and my manufacturer and description if I assigned one, but I also get my sensors to be tied with my motors, to be tied with a push button and a circuit breaker. So now I have all these different components to my entire design, all comprised on a single sheet. So I'm no longer having a separate bill of materials between our mechanical group and our electrical group. So that was kind of my high-level overview of how communication can be enabled between SolidWorks Electrical Schematic and SolidWorks 3D Design. So I thank you for tuning in today to our Break to Educate. I do want to make you aware of some upcoming events for CAD Dimensions. We have a hands-on test drive tomorrow in our Rochester office. So we're located in Rochester and want to get some more information on SolidWorks. So this is a SolidWorks only hands-on test drive. Sign up for that tomorrow. We have a simulation hands-on test drive in our Syracuse office next week. We have our rollouts coming out next month. When I look at our rollout schedule, we can see that we're coming to an office near you. Bring this over. So we're in Albany on October 7th, Syracuse on October 16th, Rochester on October 21st, and Buffalo on October 23rd, with our locations at some nice restaurants. Again, you can register right on our website. In case you need to send this video to someone else, or if you missed anything that CAD Dimensions has put on over the past couple years, you can connect with us right from our website. Our YouTube channel has all the videos and all our lunch and learns that we post, as well as our blog, which is getting updated multiple times a week with user input. Our AEs are blogging about projects they're working on, things that excite them, any tips and tricks that can help you do your job better. Sasi just posted one about surfacing, Dave posted a SolidWorks challenge, and then all our rollout information is also on the blog. So check out the tools that we provide. Again, thank you for tuning in, and have a good Wednesday.